These are your 10-2C notes, simplifying radical expressions. Just going to refer back to our radical checklist. Remember, you have to always take out the perfect square factors. If there's any perfect square factors under the radical sign, you have to take those out. We're not really going to focus on that checklist. We've spent 2 days on that already. The next two check marks or checklist items are what we're going to concentrate on today. So you cannot have a radicand as a fraction. So if there's a fraction under the radical sign, we need to get rid of it. And then the second point is that you cannot have a radical in the denominator of a fraction. So to do that, we're going to use the quotient property of square roots, which basically says if you have a radical of a fraction, you can take that square root of the numerator and put it over the square root of the denominator. And so that's how you alleviate that second check mark. Is if you have a fraction under a radical sign, you separate it into two different radicals. And then from there, if depending on that square root of the denominator, if it's perfect, it'll turn into a whole number, no big deal. But if it's not perfect, there's a method called rationalizing the denominator, and that is the method that we use to get rid of a radical in the denominator. So if you have a radical in the denominator, we're going to rationalize the denominator. And basically what that means is you make it a rational number. Rational numbers are not radicals. They're nice numbers. Okay, so for number one, let's just start off nice and easy. For number one, we're going to take this 2/9 and we're going to rewrite it as the square root of 2 over the square root of 9. And then I realize that there's a radical in the denominator, but it's perfect. It's a whole number. So remember, some of you guys are going square root of 3, square root of 3. That's not what it is. The square root of 9 is perfect, so it turns into a whole number. So the square root of 2 remains the square root of 2, and the square root of 9 transforms into 3. So I look at my checklist. There are no perfects in the radicand. Square root of 2 cannot be broken down any further. It's done. There are no fractions under the radical. We took care of that by separating it, and then we took care of the radical in the denominator by simplifying the square root of 9. So this is your final answer, the square root of 2 over 3. Number 2, we have the square root of a fraction, so we're going to fix that by rewriting it as the square root of 3 over the square root of 4. Now we have a radical in the denominator, but again, it's perfect. So we leave that as the square root of 3 over 2, because the square root of 4 is just 2. Number 3, one more time. We got the square root of a fraction. So the very first step that I want to see on your homework is separating it into two separate radicals. And then the square root of 1 is perfect. It is the smallest perfect of 1. And the square root of 16 is 4. So we end up with 1/4. So in number 3, all of the radicals went away. In number 4, we get the square root of 7 over the square root of 36x squared. 36 is perfect, and so is x squared because that exponent is even. So this is going to become the square root of 7 over 6x. You take the square root of 36, which is 6, and you take the square root of x squared, which is just x. And so that's finished. Okay, now you may be asking what happens when that radical in the denominator is not perfect. So I have for you a few examples where that's going to apply. So in number 5, we're going to take the square root of 7/5. The very first thing we're going to do is we're going to separate it into the square root of 7 over the square root of 5. But I can't leave it that way. You cannot leave the square root of 5 in the denominator. So this is where that whole process of rationalizing a denominator comes into play. In order to keep the value of a fraction, I just want to do a timeout real quick on fractions. If I have a fraction 1/2, in order to keep its value as 1/2, I can multiply the bottom and the top by the same number, and I get an equivalent fraction, meaning it looks different than 1/2, but it's still equivalent to 1/2. 10/20 is half, right? And so I can also divide by certain numbers. I could divide by 5, divide by 5, and I'd get 2/4, which is still a half. So the rule of fractions is whatever you do to the denominator, as long as you do it to the numerator, it still holds its same value as a fraction. So I don't want to change the value of square root of 7 over square root of 5, but I want to change how it looks. And so the easiest way to get rid of a radical in the denominator is to multiply the denominator by itself. And I'll show you why in just a second. So I'm going to choose to multiply by the square root of 5. Whatever I do to the bottom, I also have to do to the top. We're back to our power property, or our product property, where you can multiply. And so what this results in is 7 times 5 is the square root of 35 over square root of 5 times the square root of 5 is the square root of 25. And so by multiplying by the square root of 5, I created a perfect square in the denominator. And so the square root of 25 turns into 5. And the square root of 35, I look for perfects that live inside it, but there are none. And so our end result is the square root of 35 over 5. Now, a lot of people are tempted to make that 35 turn into a 7 because they say 5 goes into 35. But remember, that's not a 35. That 35 is representing a decimal that you multiplied to get 35. That square root of 35 is really 5 point a decimal. And so it's not a whole number 35. It's only 5 point something. So 5 cannot simplify that 35. Let's try another one, number 6. We got the square root of 10 thirds. So the very first step is to separate it into the square root of 10 over the square root of 3. Okay, so now I got rid of the fraction. Now that we got rid of the fraction, I have a radical in the denominator that I need to get rid of. So I'm going to multiply by the square root of 3, multiply by the square root of 3, and in doing so, I create a perfect square in the denominator. And so 10 times 3 is the square root of 30, and 3 times 3 is the square root of 9. The square root of 9 is 3, so it replaces it. And my final answer is the square root of 30 over 3. Again, you cannot simplify that 30 and 3 because that 30 is really not even a 30. It's the square root of 30. Let's try another one. Just lots of repetition of examples here to help you guys learn. So I'm bringing in some variables now. So I'm going to rewrite this as the square root of 2 over the square root of 3d to the 5th. Now what I recognize here is that 3 is not perfect and d to the 5th isn't perfect, but I could take something out of that. And so I'm going to take it out now so that I don't make this problem too big. I'll show you another way to do it. So I'm going to rewrite this as the square root of 2 over the square root of 3 times the square root of d to the 4th times the square root of d. So if you remember that strategy of rewriting as a perfect and a non-perfect. So when I do that, I'm going to simplify this. It's going to give me the square root of 2. And then I'm going to have that space out in front in the radical. The square root of 3 is going to go inside the radical. The square root of d to the 4th becomes d squared on the outside. And the square root of d stays inside. So I took out a perfect d squared because you cannot leave a perfect inside there. And I got rid of the fraction. The last thing I have to do is get rid of that square root of 3d in the denominator. And so to do that, I don't need to multiply by the d squared. The d squared is not hurting anything here. D squared is allowed to be in the denominator. The only part that I need to remove is the square root of 3d. So I'm only going to multiply both top and bottom by the square root of 3d and not the d squared. So when I do that, it's going to work down below. Square root of 2 times the square root of 3d makes the square root of 6d. And then I have a d squared on the outside. Don't forget about it. And then the square root of 9d squared. 9d squared, when you simplify it, turns into 3d. So the square root of 9 becomes a 3, and the square root of d squared becomes d. So now I just need to multiply these two together, and that gives me 3d cubed. So my final answer is the square root of 6d over 3d cubed. You can't do anything with those D's, and you can't do anything with that 3 and that 6. Okay, it's very tempting. That's not a 6. That 6 represents a really ugly decimal. So that's your final answer. All right, let's go up to the top here. Square root of 7x over 8. First thing, we're going to get rid of the fraction. Square root of 7x over the square root of 8. The square root of 8, I know, has a perfect living inside it. So I'm going to rewrite that as the square root of 7x over the square root of 4 times the square root of 2. I just broke up 8 into a perfect and a non-perfect. The square root of 4 becomes 2, so I have 2 root 2 in the denominator. So right now, square root of 7x over 2 root 2. Sometimes it just helps to rewrite the problem and clean it up. I don't have a problem with the 2 on the outside. The only thing I have a problem with is the square root of 2. You cannot leave the square root of 2 in the denominator. So I'm going to multiply by the square root of 2 to make it perfect. Whatever you do to the denominator, you also do to the numerator. And so my answer here, 7x times 2 is the square root of 14x. And 2, don't forget the 2 on the outside, times the square root of 4. Because the square root of 2 times the square root of 2 is 4. The square root of 4 becomes 2. The 2 on the outside and the 2 from that radical make 4. So my end answer is the square root of 14x over 4. And that's it. All right, let's try a couple more strategies. I just want to show you a few more. And I want to show you a couple different ways that we can solve this. So for 10/15, I'm going to show you in different colors 3 different times this one problem. I can take 10/15 and I can recognize right away that I can divide that and simplify that and make that 2/3. So I can reduce 10/15 into 2/3 just by dividing both top and bottom by 5. Then I can separate that into the square root of 2 over the square root of 3. Can't keep it that way. If I multiply the bottom and the top by square root of 3, I'll get the square root of 6 over the square root of 9. The square root of 9 becomes 3. And so my final answer is the square root of 6 over 3. Okay, that's one solution to this problem. Another solution is not even reducing it and just keeping it as the square root of 10 over the square root of 15, separating it into separate problems. Okay, multiplying both top and bottom by the square root of 15. When you do that, you get the square root of 150 over the square root of 225. The square root of 225 is 15. And so you get the square root of 150 over 15. But I got to look at that square root of 150, and because I'm working with such large numbers, I'm thinking I can take something out of that. I know 25 goes into 150, so if I rewrite that as 25 times 6. So the square root of 25 times the square root of 6 is 150. Put that over 15. The 25 becomes 5. So I end up with 5 root 6 over 15. And then do you see this 5/15 here? Because they're both outside, you can simplify them. That's a whole number 5. That's a whole number 15. If I divide both of them by 5, I end up with the square root of 6 over 3. So that's another way of doing that, but you see how many more steps I had to do because I didn't simplify the fraction first. So it did pay in the red work to reduce 10/15 first so that you have smaller numbers. When I worked with the larger numbers, I had to clean them up later on. And you can just tell by the work, it's a little bit more work. I'm going to show you one more strategy. This is my favorite strategy. I like to use the product property just a little bit differently. So if you remember, when we would split these up, okay, you got the square root of 10 over the square root of 15. That's always going to be your first step with fractions. But a couple days ago, we learned how to break apart square root of 10. We'd write it as a perfect and a non-perfect. I'm going to think differently, though. I'm not going to write them as a perfect and a non-perfect. I am going to write them as a common factor. So 10 has the common factor 5. So we're going to rewrite this as the square root of 5 times the square root of 2. And 15 I'm going to write as a common factor square root of 5 times the square root of 3. And by doing that, now that we have a product, now that it's multiplication, I can cross off these common factors and get rid of them. I have a square root, I'm multiplying by the square root of 5 and I'm dividing by the square root of 5. It's like it never happened. And so now I'm right back to that square root of 2 over square root of 3 times both by the square root of 3. And I end up with the square root of 6 over the square root of 9, which is 3. So I ended up with the same answer again. All of these are okay. Okay, I want to show you because I want you to understand that sometimes the blue work is better. Sometimes the green work, hardly ever is better, but sometimes that's what you do. And sometimes you'll see the red work. And so what I want to mention is there's more than one way to do these. A lot of times I need to see your process to be able to help you. And sometimes there's a better way. In this particular case, I think the red is the best way to do this problem. But all of these work. And some of the issues with these is just kind of going with something like what feels right to you and go with it. And then I can help you along the way. All right, number 10, same idea. I'm going to do the blue work again just to kind of introduce you to that. So we're going to rewrite this as 20x squared, or the square root of 20x squared, over the square root of 24y. And then I'm going to break it apart because I know that 20 and 24 both have a 4 living inside them. So I'm going to break that up into the square root of 4 times the square root of 5 times the square root of x squared. And then the square root of 4 times the square root of 6 times the square root of y. The square root of 4's cancel. We don't even need to call them 2's. They just go away. I mean, you can say it's 2 over 2, but then it'll cancel anyway. And so to clean up the top, the square root of 5 is going to stay inside, and the square root of x squared is just going to become an x on the outside. On the bottom, they're both ugly. A square root of 6 times the square root of y just becomes the square root of 6y. So to clean this up, we'd multiply by the square root of 6y, multiply by the square root of 6y, and I end up with x times 30y, square root of 30y, over the square root of 36y squared. And 36y squared ends up being 6y. So my end result, x times the square root of 30y all over 6y. Do not touch that 6 and 30. Do not touch that y. The y on top is not even a y. And that 30 is not a 30. It's an ugly decimal. And that is the simplified form for number 10. So good luck, a little bit more difficult. So your summary, how do you actually go about rationalizing a denominator? What's the process? What do you do? Just in words, what do you do to the fraction or the numbers? And then I want you to simplify the square root of 5/10. Good luck.